Hello and good afternoon. I'm Neil Knobloch, and I have the privilege of being the educational consultant on this project. Welcome to today's webinar on computational skills development for next generation agri-science professionals for sustaining data-driven agriculture. This is a USDA-NIFA Higher Education Challenge Grant, and it has been led by our project director, Dr. Dharmendra Saraswat, University. Assisting him today or with this webinar will be a postdoctoral project coordinator. His name is Dr. Anas Ahmad. He will provide the technology support and make sure that all our videos play accordingly. This project consists of 12 co-project directors from Purdue University, Tuskegee University, and the University of Kentucky. And you'll get to see our colleagues here throughout the webinar. This project developed a curriculum in agri-science informatics, emphasizing computational thinking and software development skills. As I mentioned, 3 universities collaborated to ensure that our graduates are ready for data-driven roles in agriculture. And we're going to feature 4 different courses/product components from this project. And so we're going to begin today with the first segment. There are 15 different segments. And the first segment is going to be a 5-minute overview of the project as a pre-recording from our project director, Dr. Dharmendra Saraswat, with about 10 minutes of questions following. Please put your questions in the chat, and I will help facilitate that when the video is done playing. And so Anas will begin the video at this time.
Hello and welcome to the webinar. My name is Dharmendra Saraswat and I am a faculty member in the Department of Agricultural and Biological Engineering at Purdue University. My team of colleagues and I are happy to discuss a USDA National Institute for Food and Agriculture funded project titled Computational Skills Development for Next Generation Agri-Science Professionals for Sustaining Data-Driven Agriculture. I feel honored to be the project director, which has the support of 12 other colleagues from the University of Kentucky and Tuskegee University besides Purdue University. I would like to provide you a brief background. The project was funded in 2020, and at the time of writing, the project team felt that a transformative undergraduate and graduate student course curriculum in data science is needed for solving pressing problems in agriculture ranging from food insecurity to disease forecasting. Prior to the project submission, a survey of alumni provided us the needed push for proposing this project, as the survey made it evident that students in agri-science departments needed training resources to improve computational thinking, software development, and edge computing skills. The survey rated these skills to be critical in rapidly digitizing farms and the food chain, and also in academia. The project team was of the view that problem-based learning and inverted classroom was needed for active student participation. For wider use, such content was felt needed to be made available to other land-grant universities and industry. So the background led to formulation of 2 major objectives. The objective number 1 was to develop a 2-week course module which was proposed to be integrated into existing courses offered by participating faculty in the 3 campuses, and also develop 3 new semester-long courses. The new courses were aimed to build career-specific computational thinking and software development skill sets, and also increase students' competencies for agricultural informatics career. The objective number 2 was to create a collaborative environment and cultivate open source communities in agriculture beyond the proposed courses through experiential learning, professional development experiences, and publication of course materials. As far as the novel pedagogy goes, the initial course content release efforts included the use of open courseware via GitHub, thereby enabling partners to simply customize the materials at their respective campuses. The course materials were version controlled, so each changes made by the instructors got propagated seamlessly to each other's learning repository. The instructor used their own university's learning management system to manage grades and other FERPA restricted data and communications. Instructors also hosted a virtual learning community via a Slack workspace with all students across each of the institutions and the teaching assistant participating on the same platform. This virtual workspace allowed for real-time chat and communication among the students and instructors, supporting peer-to-peer learning through a dedicated support channel, community building via shared resources and discussion, and other forms of inter-university learning. Hackathon has proved to be a very useful experiential learning opportunity. For pedagogy support, the project team relied on the expertise of Dr. Neil Knobloch, and course evaluations were conducted by Dr. Tanya Dvorak. The collective efforts by the team have ensured that over 4,500 undergraduate and graduate students have benefited from the courses and experiential learning opportunities. 3 peer-reviewed publications and numerous conference publications have also been contributed by the project team. I welcome you to listen to other colleagues describing other components of the project. Thanks in advance for your patience and participation.
All right, and thanks for sharing that introduction, Dharmendra. At this time, we're looking for anybody who has a question about the project, kind of at the larger scope level. Feel free to share that in the chat. I'll go ahead and get things started. And Dr. Dharmendra, I see that you are on, so I'm going to ask the first question. As the project director and involving 3 different universities, 12 different faculty from different disciplines, what did you see were the benefits and very positive outcomes of doing this project as a multi-institutional higher ed challenge project?
Thank you. Thank you for the question. It's very interesting and very appropriate. The question of being part of such a large group was never perceived as a challenge by me, just because of the fact of a very high degree of collegiality that I've experienced for the last 4 years. So each member not only contributed in the formulating the project, but they sustained their interest in contributing to the course content, to developing the pedagogy, to completing the course evaluation, and you can name any other aspect that I have described related to the course. So I would just use one term, that it has been a tremendous honor for me to lead this very collegial team that believed in team working. And as a result of that, I did not experience any challenge at all. So my only takeaway message will be that if you are looking forward to writing a multi-state project, please pay attention to our names. We will be very happy to collaborate with you. Thank you.
All right, excellent. So it sounds like you had a really collaborative and collegial group of colleagues, and it worked out really well. At the beginning of this project, there were it was during COVID, and there were some online, how would you say, strategic planning sessions, if you will, or what workshops we call them. Could you explain what we did, and how do you think that helped bring everybody together from our different perspectives on the curriculum development workshops?
Yes, and one thing I would like to mention here is that uh, when this project was launched, we were going through once in a century type of a situation. The COVID was there. Uh, but COVID also made us learn uh, to communicate and collaborate through virtual platforms. So many of us who are based in Purdue were able to see each other face to face, but other partners were all available virtually. Uh, we were meeting on a very regular basis, almost on a monthly basis for the last 4 years. But the formulation phase involved saw us meet very frequently. That means every second week we used to get together, and uh, the instructor, the course leads, I would say, they would present their ideas, and the other team members would just weigh in, and I would uh, say it very open and loud, is that Dr. Neil Knobloch was very forthcoming with his expertise in terms of weighing in as to what would be an advancement in communicating the new coursework that we are developing. So essentially, I would sound like I'm repeating myself, but it was the collaborative environment, the teamwork, and faith in each other that uh, made us pull through all the new courses and also deliver it to a large number of students.
Excellent. Um, and thanks for that explanation. So we have a question in the chat. It looks like there's interest in resources and publications maybe being posted and shared. So if you would want to do that after you're done with your segment, that'd be great. And then how many students, different students, were beneficiaries of this effort? So when we add up the total, and all the different courses that were taught, different semesters, do you have an estimate of the number of students that were reached?
You see, I do not have the final breakup before me, but I'm just providing uh, a thumb estimate of what my impression is. And it seems like out of 4,500 students, or over 4,500 students that I'm talking about, uh, 4,000 plus were undergraduate student, and a lot of credit of having such a high number of students being impacted by coursework is also credited to another team member uh, uh, who is teaching the data mine courses in Purdue. Uh, and A majority of the students who went through the data mine program uh, were also able to utilize the material that we developed for 2-week module, or many a times it happened that we were able to incorporate the material developed for net data mine program to offer it to other courses and campuses that we were able to reach out to. So
Yeah, so,
roughly 4,000 plus were undergraduate, and 150 to 200 were graduate students over this entire period.
oh, fantastic. Over 4,000 students. So that's great
Yeah.
to hear. And I'll just do a quick summary here. Project sustainability was built in that this is now part of the curriculum or curricula at 3 different universities. And they're also going to be open source. So everybody who wants to take a look at these and see how they might fit into their existing courses across the different universities around the world can do so. So any comments about project sustainability, and we'll pass it on to the next segment.
Yeah, I think you have said it very clearly that we have done everything to make this sustainable. And since Dr. Raturi is on the webinar, so she can provide more details on the efforts that she has made. She has been offering the the courses on a temporary basis, but now she has a permanent number. So that gives it sustainability, at least on Purdue campus. same way, I'm pretty sure that Dr. Joe Dvorak and Dr. Joseph from Tuskegee University or Dr. Faith will be able to comment on what efforts they have made to sustain this effort beyond the lifespan of this particular project. All in all, I can tell you that we are making it possible to continue teaching these courses so that the students can continue to benefit from the new knowledge that we are bringing to them. And we can also benefit from the experiential learning opportunities that they are getting through hackathon and other kind of events. I would also like to mention that one of the students who was part of this particular initiative could land a very interesting opportunity that he credited to the coursework that he had gone through under this program that helped him land sort of a dream job for him. So, and I'm if I'm not wrong, I think he is participating in one of the segments in this webinar.
Excellent. Well, thank you, Dr. Saraswat, for your leadership and for giving us an overview of this project. So at this point, I'm going to hand this off to my colleague, Dr. Dennis Buckmaster at Purdue University. And Dr. Dennis, you already have one comment in the chat you can address after the video. Thank you.
Very good. Well, thanks, Neil and Dharmendra. It was really fun to be a part of this project. I gained from it personally, to be very honest, as we included this 2-week module, which is an introduction to Python with agricultural applications built into it. Was taught in a course that I teach, which is primarily, and the students call it the Excel course. So building on Dharmendra's comment about algorithmic thinking, very much we do spreadsheets in an algorithmic way that is a logical, this thing before that thing before the other thing, sort of an architecture. And we find that that's really a good on-ramp to programming in any particular language. So we'll go ahead and play the clip here. It was an interview with Professor Krogmeyer, who taught this, he and his students taught this 2-week segment. And then we have some students that participated in it to get their reaction. So Anas, if you could just play the clip and then we can comment, and feel free to pose questions in the chat while the clip is playing if you'd like. Well, thanks, fellas, for joining this little conversation, which is about an introduction to Python 2-week module that was put together as part of this USDA-NIFA Higher Education Challenge Grant. It was a joint effort between Purdue University, the University of Kentucky, and Tuskegee University. This particular module was actually developed by Professor Jim Krogmeyer, colleague and friend here at Purdue, who's here with us along with some students and former students. So Jim, just to kick it off, this was an introduction to Python, essentially for agriculturalists, I guess you'd say. What was the focus of this particular effort?
Thanks, Dennis. The focus really was on a quick introduction for people who had very little background in programming or computational thinking, but needed to use the tools of Python to expand the computational capabilities that they had. And so we were attempting really to go from the very basics to some interesting applications that could build on spreadsheet analysis and things like that that had been done by the students before. So it had to go very fast. It was organized in a set of 4 lectures and 2 homework assignments.
So what in that 2-week module, a little bit of lecture demo and a little bit of assignment. What was the implementation like? Like what kinds of things did they do?
Yes, well, we based it on Jupyter notebooks, and the lectures were actually a series of working through these Jupyter notebooks with various examples. The students had the ability to get that notebook off of GitHub themselves and follow along in class while I was working through it. One of the nice things about a Jupyter notebook is it shows you a little block of code and then you can run the little block of code and see the results. And so a fair bit of the very first lecture was just understanding the basics of how data is stored in Python and what are the different storage types through some rather trivial examples. Following then, to try to build fairly quickly up to something interesting, some data wrangling, things like that with data that might have been taken off of a web page, say the USDA-NIFA's web page. Then there were also assignments, which were in most cases building on something that had been started in the lecture, but a coding task that was left undone. Maybe an outline was given, and then the students would fill that in, and then we would work it in the lab.
Great. So I'm suspecting for a lot of these students, it's the first time they ever opened a Jupyter notebook. So in addition to introduction to Python, it's like introduction to computing in general.
Yes, and in fact, we had a number of videos and things that showed students how to set up GitHub pages, how to install VS Code in various environments, how to use an environment. There's a cloud environment called My Binder that they were able to use. We were trying in most cases to kind of get around some of the problems that happen when we're trying to get a system set up on disparate sort of computers like they might have. That's still a work in progress because that's always kind of hard, but we were doing various things to do that. And some of the work that they did in the labs was getting their system set up.
Mm-hmm. So I guess maybe the students can chime in on this a little bit too, but that terminology, for example, in GitHub, what in the world is a fork and how do I replicate a repository and make my own? Like there's just a lot of terminology in the computing space, which was new. Let me just turn to students and just by way of quick introduction. Josh Bailey here is a grad student currently at Purdue in agrobiological engineering. Jackson Lyons is an undergraduate in agricultural systems management. He can comment on concentrations and minors as well. And Adam Shook is a relatively recent grad of Purdue, AgriCon, ASM, and also an ABE graduate degree. All of them experienced this introduction to Python. So I'm looking to you fellas. Maybe you might be able to tax your memory a little bit, I suppose. But what were the data problems and the coding challenges that were posed that you tackled during these 2 weeks?
Yeah, so like James had already kind of mentioned, he talked about getting down to the basics and the nuts and bolts and things. So really working on like string manipulation and like he mentioned, data wrangling, figuring out how to basically manipulate the data before you even start analyzing the data.
Yeah, we also did a lot of applications-based coding. So we spent a good amount of time with like USDA wheat and corn yield data, as well as breaking it down to county level data, and then using Python packages such as matplotlib to make visual comparisons.
So I am remembering, just before we go to you, Adam, I am remembering, Josh, some of what we did there were things in Python that you also did previously in Excel. So you were, to a degree, comparing the power of one approach to another. Is that right?
Yeah.
Sorry, go ahead.
No, you're good. When I actually took the course, I took a more ArcGIS focused course, and that's when I took this 2-week module. So I was working a lot more with shape files and things like that, but a lot of the same principles applied, and a lot of the same things is what I was able to take away from it.
So again, to students and former students, how did this 2-week module benefit you? Like, what did you take away from this very brief introduction to Python?
So for me personally, I think we kind of all fell in the same boat a little bit. It was a nice jumping off point because this was really my first, dive into handling coding and learning a coding language, and Python was a really good way to get a good basis set up and understand some of the principles of coding.
Yeah, I definitely agree with that. I thought it was a great intro to Python coding, good applications in agriculture or data analysis, especially for students like myself who didn't have much experience with programming. And I also thought it was helpful learning how to set up some of the tools such as Visual Studio Code which I've been able to use later on in other courses as well.
I would say the same thing as Dr. Krogmeyer mentioned. Getting on GitHub, getting onto Jupyter Notebook, getting on VS Code, all of these things apply to more than just Python. And then learning Python as a good way to learn how to code and how to learn how to code. It applies to other languages, and it's just a general temperament for data analysis.
Good. Well, from any of you, highlights of this particular part seem to really go well, or there was a little hiccup maybe in version 1 and we got better by version 3 or something like that. What's top of mind?
I'd have to dig back a little bit better to get a specific example, but I thought overall it just flowed really well. The way the course was laid out and structured, it didn't seem like there was any breaks, and it seemed to make sense going all together. And it was just like a whole. It didn't seem like 2 weeks. It seemed like a nice long kind of continuous stretch. So.
Yeah, I thought after we learned some of the basic diction and functionality, which not all Python courses teach, I thought we were able to cover a breadth of material just in 2 weeks, and it was good to gain hands-on experience as well.
Yeah, I think it really worked well. Some of the hands-on lab experience, as well as, like Jackson mentioned, the structure of everything going through, like on the Jupyter Notebook, it really flowed well as a course. You could go through, enter the code, run the code, and see some examples, and as well as enter your own code.
Those are heartening things to hear. As an instructor, I think I could perhaps see things where we changed a little bit over the time. I mean, you guys each sampled one sample of it. I felt a little like the data wrangling got a little bit tedious as I went, and especially since in many cases you're teaching a very basic thing at the start in order to introduce a more powerful tool, and Python has, of course, very powerful tools. That's one of the reasons that Python is such a useful language to learn, because of these libraries and packages that you can use. So in one case, there's a package called Pandas, which really automates the dealing with spreadsheets and column data, row data. I think we kind of lessened that as time went on. We went to the more powerful tool a little quicker. And there were a few other things as well. I think, where sometimes when the material was put into the lab, it was clear that it was a lot harder than I thought it was to grasp it. And of course, you also saw quite a range of kind of computational ability in the group of students, some who had done a fair bit, and some who had never done any, yet we're trying to bring them all together, which did work. You just had to sort of stick with it. And the students were really game for that. And I was happy to see that.
Super. Well, we're tight on time. I guess my closing question would be to Josh, Jackson, and Adam. And again, thanks for sharing your experience here. What has been your coding journey after that quick introduction? What's happened since then for you?
So I've had at least one more class that dealt largely with handling ag data and processing and stuff, working with RStudio in the majority of that.
I've been able to continue on for my master's in ABE with a focus in data science, and I've been able to take courses such as ag informatics, which dove more into Python as well.
Yeah, throughout my career, the rest of my time at Purdue, I took multiple courses that involved coding. Now, whether that was RStudio or HTML and CSS or more Python, as well as for my thesis, working a lot in different languages to pull that project. But then now in my career at Caterpillar, kind of serving the list and all of these techniques, a lot of these tools, and just kind of the general knowledge that I learned from not only this course, but my time at Purdue, that has played a huge impact on my career, and it's something that I use every day.
Great. Well, thanks again, all of you, for sharing a little bit, and look forward to seeing your successes on into the future. Okay, so that was your little introduction video, a little bit of student reaction in there. I did answer one of Professor Raturi's question in the chat, had to do with what would be helpful for the students to do perhaps next, which was, I think, more exposure to other functions and libraries in Python or the other languages that they're learning. And to do that with applications in mind, either answering some research questions or management decisions, seems to help to motivate their learning. But I think exposure to the libraries was like it continually extend their programming capabilities, just different structures, for loops, while loops, things like that would be good. There was another question there about what was our experience with the My Binder, essentially opening Jupyter notebooks without installing anything. We had mixed experiences because it's completely online, click a button and it goes. The convenience of that is really hard to beat. However, when many students are doing it at the same time, sometimes we got caught in the waiting mode, waiting for My Binder to actually launch. And then occasionally you would have to reset the kernel, sort of relaunch things. However, it still was a good experience. The students had to learn about what is currently known in the cloud and what did I actually save to my local computer or to my GitHub repository. So it actually stretched them a little bit in terms of, I guess, a little bit of version control and exactly where is the thing, the code or the data that they're working with. So in general, pretty good experience with My Binder. However, in the last round, we actually used VS Studio, Visual Studio, VS Code as an environment. So we had them set that up on the computer and then run their Python Jupyter notebooks from there. Okay. Well, those are the questions that I had. I think I'll go ahead and pass it on to friend and colleague also, Dr. Ankita Raturi. She's also here at Purdue, and she developed the Introduction to Ag Informatics course. So I'll let her take it from here, and I believe there's also a little conversation about that course.
Yeah, thank you so much, Dennis. And Anas, why don't we just roll with video first? Hi, folks. My name is Ankita Raturi. I'm one of the faculty instructors and the designer of the Introduction to Agricultural Informatics course. And today I'll be speaking with Anas Ahmed, who is a graduate teaching assistant in 2021 for the course, and Stephen Doyle, one of the students turned TAs during 2022 and 2023's offerings. I wanted to share a little quick bit about the course itself. Intro to Ag Informatics is really designed to be a sampler course. We give students experience with a wide variety of languages, really trying to help them build their skills from the ground up. And so while our objectives include learning some of these core skills in design and data analysis and web development, we really want them to come away with an attitude of experimentation with informatics and feel confident in their ability to take an idea and really implement it, whether it's as a web application or really sort of thinking about different kinds of informatics solutions. So we ask students to follow through this iterative prototyping cycle where they spend some time thinking about user requirements, they engage in some hands-on design, and then actually build out different kinds of prototypes in 2-week chunks. So the course is structured in these modules where every 2 weeks we introduce them to a couple of new concepts. They do a lab that is on that topic itself, and then we move on to the next piece and add some more. So in week 1, we start with web design. They learn HTML, CSS. We focus on web design fundamentals and programming fundamentals. In module 2, we add in Python, and we really focus on that data science stack, right? So really thinking about how to actually implement some data processing, cleaning up the data, visualizing it to be able to do something useful down the line. In web applications, we introduce Django, a framework for being able to very quickly prototype web apps. In data management, we then roll in SQL. So now they're playing with databases and really thinking about data structures. In module 5, we spend some time thinking about user interface, really focusing on what the user sees and how to think about usability, especially including through the use of out-of-the-box frameworks like Bootstrap. In week 6, we then start to experiment a little bit with different kinds of geometric processing or, GIS tools. And so last year we did a little bit of integrating applications like Leaflet within their web apps. And then in week 7, I usually pick something fun, something out there. Last year we did a little bit of speculative design. The year before that, we did some deep learning. And so every year I ask the students to kind of pick a concept that they'd like to really kind of experiment with. And that's what ends up in week 7. And so these are modules, right? So you can pick and choose what you want, whether it's as a learner or as an instructor, and integrate these into your courses. I really try to emphasize hands-on work. So we do a lot of drawing together in addition to coding together. We go on a couple of field trips and really try to think about how to work together in teams to be able to build different kinds of fun and interesting web applications. So let's start a little bit by hearing about some of the student experiences.
So I am an agricultural engineering student, and I came in with some Python background, but not terribly much. I learned quite a bit about processing data and about building web apps. Web apps were something that I had zero experience in before, and so I was able to learn quite a bit using the base knowledge of Python that I had. That said, there is some introductory material for Python learners and a lot of external resources that are provided in the course to help students ramp up to the level of Python that they would need in order to flourish in the course. And so it was something that myself and other students were able to grasp fairly easily while still providing a lot of new material.
In the course, I tried to include a lot of domain-specific data sets. So I remember that we had a guest lecturer come in and talk about economics. We had somebody else come in, talk about UAV use in row crop production. And so we had a lot of different discipline or domain-specific data sets, examples, and even lectures. I wonder what your experience was like, with respect to like how well did these fit with your own discipline? And then did you feel like you were getting exposed to other topic areas, and kind of how did that shape your work?
Well, the amount of different types of disciplines and the data that accompanies them that we were exposed to both in the labs and in the guest lecture portions allowed me to visualize and understand challenges that were normally outside of the scope of my particular expertise, but it also allowed me to think of new challenges, new ways to structure data, and new tools to process them. This was something that both added to my own repertoire of skills and also allowed me to understand the types of research questions that are present in multidisciplinary agricultural challenges and contexts.
So in that sense, were there certain things that worked really well for you and other things that didn't work as well?
Absolutely. There were some data sets and some topic areas that were covered very extensively, especially the web app portion and things that focused on building out a farm information management system. Then there were some parts that were not covered quite as extensively, like economics or livestock production. And these are things which could stand to be better covered in order to provide students from those disciplines with more information to relate to. But on the other hand, there's only so much room that a survey course can contain.
Yeah, no, that's totally right. I wonder, Anas, if you could riff off on that and kind of tell us a little bit about what things you saw students enjoy and struggle with, including maybe some of the different topics that they covered.
There was a lot of diversity in the way the course was taught. There was like assignments, there was a lot of hands-on, there was like guest speakers. I think a lot of students really enjoyed the way the course was structured, and it was definitely something like that was like a little bit more new the way it was introduced. And then obviously all of the assignments that were provided and that were developed, I think those are very applicable to real life scenarios that would then go on to help each of the students in their careers. So because everyone got a taste of everything like programming, web development, even a bit of deep learning towards the end of the course, I think students were really happy about what they took away from that course.
And in that sense, Steve, do you feel like the things that you learned helped you in your sort of subsequent efforts, whether it was in your research or in sort of other parts of your career?
Oh, they certainly did. I had not had the opportunity to understand how to build a web app before. That's something that the agricultural sciences almost never cover, and yet it's something that farmers are more and more being or leveraging in order to complete tasks around their farm. And so being able to learn how to build one and then how it could be used on one's own farm or one's own research context is something that was very valuable. And it's something that I definitely hope to continue in my research or in my career afterwards.
Yeah. Us in that sense, I know that we had some areas where I feel like everyone was kind of cooking with fire. So like data science, or at least a Python module right up front, was pretty straightforward. But as things got harder, I know that there were particular types of challenges that students were having. If you were to identify things that students could do to kind of mitigate some of the challenges with doing some of those more complex pieces, like the web app development, are there things that come to mind for you?
That the first thing would be either at the beginning of the course or right before the course, start to gain an understanding using a lot of the resources that are available online, or even the optional materials that accompany the course, to really understand the fundamentals of a programming language. That's something that is pretty foreign to agricultural students, even in agricultural engineering. And understanding that will allow students to say understand the logic behind the phrasing that they're using in order to process data, and understanding that basic logic will really help them when things get complicated with web apps. So
Yeah.
that would be my main recommendation.
As a TA, what worked for you and what didn't?
So a lot of the content, there were like sometimes there were like wrinkles. But then just overcoming those and like redoing any assignment right before the lab, those were some things that were very beneficial. And then recording any errors or problems that I would face while I was doing them, because then it was like each student would face the exact same thing. So I would know exactly how to help them.
Yeah, yeah.
That was
So you
really
were actually
strong.
doing the assignments and keeping track of the bugs that you were encountering, so you were almost able to
Mhm.
predict the students were going to experience.
Yeah, absolutely. I do agree with Honest. The best thing to do is, after you've gone through a lab yourself as a TA, you should identify the parts that you had trouble with so that you can highlight those when you're giving an overview of what students will be doing, as well as to be able to quickly troubleshoot any problems that they have. I think that one of the things that can be challenging for students is really grasping the fundamentals of how say a web app works, or how a Python operation works. And so being able to have that explanation ready in a way that's accessible to them is something that is definitely very useful as a TA, because as it turns out, every student has a different thought process when they're trying to solve a coding challenge. And so that means even if you go through a lab and you complete it in a way that you think is the most efficient or makes the most sense, there's plenty of other ways to accomplish the same thing. And that means there's plenty of other ways that a student might encounter challenges. And so trying to explore from different angles is something that can help once a student reaches a point of having a challenge in their particular line of code.
Yeah, yeah. It's funny. I remember when I was writing the labs, I was like, because I was so focused on the way in which I would solve the problems and with my own experience, it meant that I would definitely do them like a computer scientist would. Like there were certain things I just assumed as best practices when I was creating the labs to begin with. And so it was kind of delightful being able to both work with each of you and see your different ways of solving these problems, sometimes coming up with more efficient methods, but then also figuring out ways to break it down for students in sort of ways that I took for granted sometimes. So as you were trying to bridge this sort of gap between people who have a technical, computing background and those who maybe were more of had a technical agricultural background, what were some of the things that you did as instructors to help bridge that gap for students?
Yeah, so I was just because I did my undergraduate studies in computer engineering and then my PhD in electrical and computer engineering. So a lot of the programming background was something that kind of had come naturally. And like you were mentioning, as I was helping develop some of those labs, I wouldn't even like think about how they would even use a library. Like students would access a library in Python, for example. But then like to really to break down the steps that, okay, maybe this is what the library is. This is how you can install it. And then this is the different ways in which you can use it. I think that was very useful. And then just like learning that along the way was very helpful for students.
Personally, the thing that helped me the most when I first started coding, and I didn't really have a formal background in that area, was just identifying a problem that I wanted to solve and using materials that were available to just tinker with code until I figured out how to do it. I think that that's something that can be useful as a motivating factor for students before they sign up for the course, and also while they're taking it, to experiment with things, try and take things one step further so that they can apply them to their own research. And that said, bridging the gap between, say, the life sciences or the natural sciences and computer science can be something that requires you to maybe take a different mindset in explaining things to students from those walks of research. I would say that it's something where a lot of using analogies focused on physical things, physical processes, to try and visualize what's going on in an abstract level is something that was very helpful.
You know, for students, it sounds like a lot of it is to come in with that tinkering mindset, but also a mindset that is open to using resources and really being engaged. And so there is a lot of self-motivation that is required to kind of tackle a very hands-on course that might be foreign, depending on if you're unfamiliar with the domain or unfamiliar with the technical challenges. It sounds like for instructors, a lot of it really is trying to be mindful of the different types of vocabularies that we might all be using and trying to make sure that we're really translating our ways of solving problems, thinking computationally to other ways of doing work. Are there any other things that come to mind as we start to close with respect to recommendations for future students or instructors of this course?
As a recommendation to future students, I would say that this course can be thought of as a gateway to a lot of the more advanced Python or remote sensing courses that the department has available. And so it's a very important stepping stone if you don't have a coding background, because many career paths these days are requiring you to at least have some familiarity with the concepts that are presented in this course and with the concepts presented in subsequent courses. So while coding may not seem like something that you would initially find very useful, you will find it advantageous in the long run. So I would recommend giving it a shot. Odds are it will help with your research and maybe even beyond that.
Cool. Anas, any recommendations for instructors?
Yeah, absolutely. So I think because we see students coming who are interested in this class from various different backgrounds, just laying that, like making sure the instructions cater towards that, and to put the instructions at the student's level rather than assuming that they already know a lot of the material from the get-go.
I want to thank you guys a lot for sharing some of your thoughts with us today. For those that are watching, you know, this is an open courseware, and so it means that this is a, you know, an invitation to collaborate with us. We are actively looking for folks to contribute new modules. We're really thinking about this as a living organism, right? As technology changes, as emerging technologies mature, we really want to make sure that we're keeping up, and that means that, you know, we're all kind of putting our heads together and really thinking about what types of materials we should be creating to really help educate that next generation of agricultural knowledge workers. So thank you all for your time, and that's all.
And I know there's been a little bit of discussion in the chat, but I think in the interest of time, I might actually just pass on to Joe so that we can hear about the hackathon.
Okay. All right, so I'm going to introduce a little bit about the hackathon. We've hosted 2 hackathons now. We've been hosting at the annual international meeting of the American Society of Agricultural and Biological Engineers. So we've, like I said, we've hosted 2 of those. They've been combinations of multiple universities, and we've had people from, you know, Purdue and University of Kentucky, as well as several other universities. The students were just attending the conference, and they have joined in our hackathon. So that's been an excellent opportunity. We are currently in the planning phases for the next hackathon, and I will let, I guess, Anas, are you ready to play the video? So thank you for joining us. I'm Joe Dvorak. I'm at the University of Kentucky, and I was the organizer for the hackathon with an excellent team. And I'm here to interview and discuss the experience of the hackathon with one of our hackathon teams. So I'll let you guys go around and introduce yourselves.
Hi, I'm Maggie Barnes. I'm a senior in biosystems engineering at the University of Kentucky.
Hi, I'm Tiffany Kugel, and I'm also a senior at the University of Kentucky in biosystems.
And I'm Autumn Denny. I am a senior at Purdue University in bioengineering.
Awesome. So we have teams that's composed of people from different universities. We'll talk about that a little more later, but first, I just want to, can you talk about what you created in your hackathon?
Sure, we could talk about that. So for the ASAB hackathon, what we worked on, we dubbed it the sensor garden. And essentially over the summer, I was working on making an indoor garden. But I am a terrible plant mother, and I had like heaps of wilted, sad plants. I always forgot to water them, so I actually bought some soil moisture sensors online and brought them to the hackathon. And my goal for that project was to create an application that would, automatically remind me to water my plants. So the soil moisture sensors would detect whenever the soil moisture dropped below a certain threshold and then would remind me so that hopefully I wasn't going to have a bunch of dead plants in my house.
Awesome. And I know everyone worked very hard on this project. So can each of you kind of tell just briefly kind of what you guys did? So I guess we'll start with you, Autumn. Do you mind saying what your primary contribution was?
Yeah, so I came into the hackathon with an idea. I had a broad general knowledge of how all the pieces would fit together. So essentially I did a lot of project management and sort of, delegating and checking to make sure that, certain parts of the team were talking together. I also set up the server and I was working on the API.
Excellent. Maggie?
I worked on wiring. I connected the ESP32 and the sensors to the Arduino. I also worked on calibrating the sensors, and I also worked on the code.
I helped Maggie with the code, did a lot of troubleshooting, and I also researched soil moisture sensors that are currently on the market, just to make sure that our project would meet the needs of our target audience and also to ensure that our design was actually innovative.
So excellent. And I know you guys had a wonderful demonstration at the end and showed off how the system ran. So I know it was successful, but switching gears a little bit, do you mind elaborating a little bit on what you thought was the best part of the hackathon? Maggie?
I thought the best part of working on the hackathon was definitely meeting other people with different interests than me. It was really cool seeing people with more of a computer science background.
Sort of along those lines, just joining a team of other engineers who were all at different points in their education and career, I thought was really interesting. And especially for when looking at the other teams at the hackathon, I thought it was really interesting to see how people were incorporating these emerging technologies we're seeing. Some teams were using like image recognition and machine learning in their projects, and I thought that was really awesome.
I would like to second that it was really great to see a lot of the variety at the hackathon. I have gone to some of the previous hackathons that the University of Kentucky and Purdue have collaborated on together before. And I have seen people do all sorts of projects, everything from plant science to projects that address socioeconomic challenges such as food availability. So seeing people's personal interests, both their academic in terms of, what they like studying and, what they want to see changed in the world is really just a fascinating experience.
Cool. And I know it was obviously a wonderful learning experience as well. So do you mind discussing what you learned? Tiffany, do you want to go first?
Sure. I learned a lot about project planning and management because the hackathon takes course over just a couple of days. So we're planning and trying to complete a project from start to finish in a really short period of time. And it was just great to get some experience, like making decisions regarding the scope of the project, choosing what deliverables we could have as a project at the end, and communicating these decisions over just a couple of days, I thought was a really great experience.
Autumn?
So personally, I learned how to kind of assess people's competencies and how to delegate work. And I also learned a bit more about what my competencies were and where I kind of fit into the project. I definitely learned how to ask for help more and definitely developing some of those people skills in a context where the goal is to make something innovative. That's a big takeaway. I had to refine some of my system administration skills as well in terms of the technical component. We had a couple people accessing our server, so I had to do a little bit of a basic info security learning and very quickly.
And then Maggie?
Yeah, I learned about the connection between hardware and software by working on the wiring and the code for the ESP32. I was able to learn a lot.
Excellent. So I know you learned a lot, but was there anything that was especially surprising about the hackathon?
I was surprised that every group was able to finish so much in such a short amount of time. We only got a few days to work on the projects.
And then Tiffany?
I was surprised by the interest that people showed in our project and just the hackathon in general. Other attendees at the conference would stop by and they would ask us questions and they would give us suggestions and share their experience. So it shows that the ASAB community is really supportive of projects like this, and it just shows that precision agriculture is something that people are interested in and they care about.
And Autumn?
Yeah, I would like to second kind of that we got a lot of attention at the hackathon. One of the best things I really got about, and definitely one of the more surprising things as well, is that having some of that attention from some of the people from ASABE actually helped facilitate some of these conversations I've been having about going into graduate school.
Excellent. I know you guys, the hackathon itself was there in the middle of the conference floor. Lots of people were coming in and out, and so you were definitely the center of attention for a lot of people. So how was it like working in that kind of open environment? And we know that there are people from across the world and all kinds of different universities that were coming by and saying hi to you. So how was that experience? And do you have any other concluding remarks?
So that experience was a little overwhelming, but in a good way. There was such a large array of different ideas and people to talk. And that's what I really felt was a good takeaway for me from the hackathon, is having that experience of talking to people. Even if it was a little overwhelming, getting to see the ideas that people had at the hackathon, people really had just a lot to bring to the table.
And then Tiffany?
Sort of like Autumn was saying earlier, with the grad school, I thought it was really great to hear about other people's experiences with continuing their education, and it just helped me make a more informed decision of whether or not I wanted to continue my education and which schools I wanted to look into more.
And then Maggie?
Yeah, it was great. We were able to experience the hackathon, but we were also able to experience the conference as well. So we were able to take time to step away from the hackathon and go see research from other people and other schools, which was great.
Awesome. Well, thank you all for sharing your experiences and participating in the hackathon this past year. So hope to see you around at future hackathons and other events, but thank you for your time. Thank you.
Thank you.
Thank you.
Thank you.
So thank you guys. That was our video talking about the student experience of the hackathon. Are there any questions? I don't believe I've seen any in the chat. Give me just a second, but otherwise I will turn it back over, I guess, to Dennis or Neil. Do you have any concluding remarks?
Well, there is a question there in the chat now about the next hackathon. I think we are planning on having one at ASABE conference in Anaheim, California, later summer 2024.
Correct. And the websites are being created right now, and we'll share more of that shortly.
Excellent. And I just appreciate everybody for doing the pre-recordings, and students for also sharing your experiences. This was an excellent webinar, packed with lots of experiences and different information, ideas. Please provide us feedback, as this was our first one, and we hope to do more. So there will be a questionnaire that you can click on. It's posted in this chat, but it will also be available if you watch it as a recording. So thank you all, and we hope to see you at the next webinar.